Hi everyone. I'm going to be doing number 2 on page 124, or chapter 5, I believe, of the Garrett Grisham book. The reason I'm doing this is because I feel like I did a lot of um, quantitative stuff, but just because this was covered in the last lecture, never really had any questions until this weekend. So kind of realize that people do need help with this. So what this says is that amino acid analysis of a oligopeptide 7 residues gave aspartate, leucine, lysine, methionine, phenylalanine, and tyrosine. Yes. The following facts were observed. Trypsin treatment had no apparent effect. The phenyl thiohydrate ion, I'm really bad at pronouncing, release at Edmond degradation was this. I really suggest that you actually maybe put a time mark on this so you can come back to this when I actually talk about it and look at the structure of it. Because I may not be able to show such a good image again. Brief chymotrypsin treatment yielded several products, including a dipeptide, a tetrapeptide. The amino acid composition of the tetrapeptide was leucine, lysine, and methionine. And cyanogen bromide treatment yielded a dipeptide, a tetrapeptide, and free lysine. So the first thing to do is to go ahead and write out what we do know. Try and figure out, that way we can figure out what we don't know. What we do know: 7, 2, 4, 6, 7 peptides long, or amino acids long. We know that aspartate's there. We know that lysine's there. We know that methionine, leucine, what was the other two? Tyrosine and phenylalanine. Okay? That's all we know at the very start. What we can assume, though, is that there's only 6 amino acids, so one of these could be duplicated. Which one, we don't know. So part A says that treatment with trypsin gave no apparent effect. Now trypsin will cut after lysine and arginine, which is R. But in order for it to have no effect, it has to be the last amino acid, because it cuts on the carboxylic side. So even though trypsin is active and it will work, it will hydrolyze the peptide bond, but there's no peptide bond over here if we put K here. So K must be here. The second one, part B, is shows us a structure, and the structure is this. And it's Edmond degradation. So you need to be able to recognize Edmond degradation. What you do need to recognize from this is that this right here is going to be your R group. So you need to recognize that this R group right here is phenylalanine. Edmond degradation will attach to the N-terminus of our polypeptide, and it will cleave off the first amino acid. So recognize your R group and recognize where you need to look for your R group in Edmond degradation, and it's right here. So that tells us that our first one's F. Our next one is chymotrypsin. and that says that it's going to give us a dipeptide, a tetrapeptide. And our tetrapeptide is going to be contain lysine. That's later. What they don't tell you is that chymotrypsin cuts after anything aromatic. So it's going to cut after W, Y, and F. So what they don't tell you is that F is cleaved off. And you know that because they only tell you there's a dipeptide and tetrapeptide, and that doesn't add up to 7, that only adds up to 6. So what we need to look at is just these 6. And how can we make a dipeptide and a tetrapeptide? We can make a dipeptide and a tetrapeptide by cutting it here, or placing a tyrosine here. Everyone see that? So if we cut it here, we're going to have a dipeptide in a 1, 2, 3, 4. If we cut it here, we're going to have a 1, 2 peptide and a 1, 2, 3, 4. We don't know which one. However, there is another clue. The clue is that the tetrapeptide contains lysine. So that means that in order to create a tetrapeptide that contains lysine, it must go over there. There's another hint too, and that's what they don't say. What they don't say is that aspartate is not included in your tetrapeptide. Aspartate must be included in your dipeptide. And the other one must be tyrosine, because that's where it cuts. So chymotrypsin will cut here, it'll cut here, forcing your aspartate to be here. So now this is what we have left. We have methionine, leucine, methionine or leucine, methionine or leucine. We don't know which ones yet. Okay. So one of these is going to be duplicated and we are not sure which ones. Our very last clue is that when we have when we treat with cyanogen bromide, we get a free lysine. The only way that cyanogen bromide will give us a free lysine is if methionine is here, because it cuts on the carboxylic side of methionine. What they also say is that it creates a tripeptide, a dipeptide, or I'm sorry, it's going to create a tetrapeptide, a dipeptide, and a free lysine. So looking at those, you know those add up to 7, so there's nothing that they're not telling you. And the only way to so methionine can either go here or here. The reason that we know that there's 2 methionines in there is because we're making 3 products. We're making a dipeptide and a tetrapeptide and a free lysine. So we know that methionine is our duplicated amino acid. But the only way to make a dipeptide, a tetrapeptide, and a free lysine is to put it here. Because what happens is cyanogen bromide will cut here. It will cut here, producing a free lysine, a dipeptide, and a tetrapeptide. Finally, your leucine will be here. So the hardest thing about these is not necessarily figuring out what they tell you, but figuring out what they don't tell you. What didn't they tell us? They didn't tell us anything about aspartate. All we know is there. We didn't know where it was, but we figured it out because they said that when we cut with a compound that cut after our aromatics, the tetrapeptide didn't contain it. It didn't say what peptide contained, and we know that it cuts after our phenylalanine. So we knew that our aspartate had to be here. They didn't tell anything about leucine, but that was just by process of elimination that we figured out where it was. So hopefully what you'll learn to do eventually is when you're going through here is try to start thinking about what aren't they telling me? What isn't being said? And that can be figured out a lot by counting, right? So in the course reader number 4, they tell you that some reaction gives you a dipeptide, a tripeptide, and another dipeptide. And if you add all those up, it's only going to equal 7, but your amino acid chain is 9. And so you know one of those is duplicated. It's the same thing here. Part C, I believe, or the one that cuts after the aromatics. What they tell you that's here, there's only 6 amino acids that they're counting for. The 7th isn't. And that's how you have to figure that out. Okay, guys, I hope this helped you out. Again, it's very, very crucial to first draw it out. Write down where your letters could all possibly be, and then by process of elimination, figure out where they're not. That's kind of the most crucial thing, is figuring out where they're not necessarily where they are. Because if you know where they're not, you know where they are. It's kind of contradictory, but that's the way I had to purchase, is figure out what isn't true. And also look for what they're not telling you. Try and read between the lines, use a little bit of logic, and hopefully these will become a lot easier if you do all those things.